In the name of God, the most gracious, the most merciful, peace be upon you, and God's blessings. We will start our discussion about the second case of Mohr's circle of inertia, where Ix is less than Iy and Ixy is positive. What are the shapes that fulfill these two requirements? We have the rectangle shape with a dimension b by h, where h is less than b. In the left corner, we have Ix equals b multiplied by h raised to the third power divided by 3, where Iy is equal to hb raised to the third power divided by 3. The product of inertia Ixy is b squared multiplied by h squared divided by 4. Similarly, in the case of unequal angle where the short side is at the left, for that case, if we apply the relation of tan 2 theta equals minus Ixy divided by Ix minus Iy over 2, we have negative multiplied by positive divided by negative equals positive. The angle 2 theta b would be in the first quarter and third quarter. In the next slide, we have two expressions for the inertia about inclined axes. The first expression is Ix dash equals Ix plus Iy divided by 2 plus Ix minus Iy divided by 2 multiplied by cosine 2 theta minus Ixy sine 2 theta. The second expression is Iy dash equals Ix plus Iy divided by 2 minus Ix minus Iy divided by 2 multiplied by cosine 2 theta plus Ixy sine 2 theta. When will be Ix dash is maximum? It will be maximum if cosine 2 theta b1 is negative and sine 2 theta b1 is also negative, since we have positive plus positive multiplied by negative minus positive multiplied by negative. This means that 2 theta b1 is in the third quarter, where the 2 theta b1 value is from 0 to minus pi. Consider 2 theta b1 as the angle from the x-axis to the u-axis in Mohr's circle of inertia in the clockwise direction. On the contrary, Ix dash will be minimal when cosine 2 theta b2 is positive and sine 2 theta b2 is positive, since we have positive plus negative multiplied by positive minus positive multiplied by positive. This means that 2 theta b2 is in the first quarter. Consider 2 theta b2 is the angle from the x-axis to v-axis in Mohr's circle of inertia in the anti-clockwise direction. In the next slide, a discussion of Mohr's circle of inertia reveals that the circle gives the u and v directions in the horizontal direction while the x-axis is tilted. For case 2, based on our previous discussion, the angle between the x-axis and v-axis is angle 2 theta b2 in the anti-clockwise direction in the first quarter. The angle between the x-axis and u-axis is angle 2 theta b1 clockwise in the third quarter. This enables us to determine the I max and I minimum after we get the radius of Mohr's circle. For the normal view, we have the x-axis in the horizontal position, so we need to rotate the x-axis and all the relevant axes u, v and y axes by an angle of 2 theta b1 in Mohr's circle of inertia. We can find that the u direction in the normal view is below the x-axis by an angle of theta b1, while the v direction in the normal view is above the x-axis by an angle of theta b2. The axis Ixy will rotate as well, and we will discuss that in the last slide. These are the step-by-step procedures to construct Mohr's circle of inertia. Number 1, draw a horizontal axis representing Ix, Iy, Imax, and Iminimum. Number 2, draw a vertical axis representing Ixy in the upward position where Ixy is positive. Number 3, locate the point which has a coordinate of Ix, Ixy. Point A is drawn on the right side, and with Ixy upward, it will be on the upper left side. Locate point B where a coordinate of Iy, minus Ixy. The point B is drawn to the right, and with Ixy downward, it will be on the lower right side. Number 5, join the 2 points A and B and cut the x-axis in point O, which is the center of Mohr's circle. Number 6, draw the circle with a radius equals to OA equals OB. The coordinate of point O is Ix plus Iy over 2, 0. Since we have Iy is bigger than Ix, the radius of the circle is equal to the square root of Iy minus Ix divided by 2 raised to the second power plus Ixy squared. Point E is the maximum value of Ix, and it is equal to Ix plus Iy over 2 plus R. Point C is the minimum value of Ix, and is equal to Ix plus Iy over 2 minus R. We can find that the line OA represents the x-axis in Mohr's circle, while axis OB is the y-axis in Mohr's circle. In the next slide, we create a mirror point A dash with a coordinate of Ix, minus Ixy, and also creates another mirror point B dash with a coordinate of Iy, plus Ixy. Why do we need that points A dash and B dash? Joining OA dash will show the UU direction when the x-axis is in the horizontal direction. Imagine that we rotate axis OE in the clockwise direction by an angle of 2 theta B1. Joining OB dash will show the VV direction when the x-axis is in the horizontal direction. The angle 2 theta B2 is the central angle shown between axis X and axis V. In the next slide, we want to get the direction of the U-axis in the normal view and its angle. Join point C with point A dash. The enclosed angle is theta B1, which is half the value of the central angle 2 theta B1. Join point C with point B dash. The enclosed angle is theta B2, which is half the value of the central angle 2 theta B2. The Ixy axis will also rotate. Consider the U-axis as your datum and modify the Ixy axis by making it parallel and to the left of a perpendicular line to U at point O and offset by a distance of Ix plus Iy over 2. Now we have the x-axis as a horizontal axis. Check for theta equal to 0. We find point E with a coordinate of Ix, Ixy. The OE distance is the radius R, and it's apart from axis Ixy by Ix, Ixy. Check for theta equals 180. We find point C with a coordinate of Iy, minus Ixy. The OB distance is the radius R. The distance Iy is measured from the Ixy new datum while the Ixy distance is negative below the U direction. Thanks a lot and see you. Goodbye.